Today we'll be working on the 12th program, implement recursive functions for binary to decimal conversion. Before we start discussing about the program, let us take a look at the number systems as we know. First, let us take a look at the decimal number system. In decimal number systems, the values are given to the digits with respect to base 10. Consider the number 1725. We know that 5 is in the 10 raised to 0 or 1's place, 2 is in the 10's place, 7 is in the 100's place, and 1 is in the 1000's place. These places are given to these digits with respect to base 10 values. And to compute the value of this number, we have to multiply 1 into 10 raised to 3 plus 7 into 10 raised to 2 plus 2 into 10 raised to 1 plus 5 into 10 raised to 0, giving us a total value of 1725. This is how we compute the value of a number with respect to base 10. Similarly, numbers in binary system work with respect to base 2. For example, consider the number 1001. The numbers are given places with respect to base 2. 1 is in 2 raised to 0, that is 1's place. 0 is in 2 raised to 1's place. Here it is in 2 raised to 2's place, and this is in 2 raised to 3's place. And to compute the value of this number, we need to multiply it by its respective places. That is 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 0 into 2 raised to 1 plus 1 into 2 raised to 0, giving us a total value of 9. This is how you convert a binary digit into a decimal number. You multiply it with the respective place values. Now that we know how to convert a given binary number into its decimal format, let us consider this format. Now I'll consider these three terms. I'll take 2 as the common factor and I'll rewrite this expression as follows. So I've taken 2 as the common factor. So now this expression reduces to 1 into 2 square plus 0 into 2 raised to 1 plus 0. And this entire thing is multiplied by 2. And 1 is left outside. Now I'll reduce this equation further. I'll take these two terms and I'll take 2 as the common term, therefore producing 1 into 2 plus 0 into 2 plus 0 into 2 plus 1. So as we can see, I have rewritten this expression into this. In each step of this expression, I have extracted the rightmost digit and I have multiplied the rest with 2. For example, here, considering these 4 terms, I have extracted the rightmost digit. I have kept the rightmost digit separate and I have multiplied the rest with 2. In the next step, I have extracted the rightmost digit and I have multiplied the remaining terms with 2. I am going to make use of the same logic to recursively compute a binary number to decimal number. So as already discussed, in my program I am going to have a function binary to decimal. During each iteration, I am repeatedly going to extract the rightmost digit and I am going to multiply the remaining digits with 2. In the next step, we have binary to decimal of 100. In this, I am going to extract the rightmost digit and remaining 2 are multiplied by 2. Next, I am going to extract the rightmost digit. I am going to multiply the remaining by 2. This is how I am going to recursively implement this function. In order to remove the rightmost digit, the logic I am using is number mod 10. And to get the remaining leftmost digits, I am using number divided by 10. For example, if I consider the number 1001, 1001 divided by 10, 10 into 100 equals to 1000, so remainder is 1. To get the rightmost digit, I have to perform mod operation. I have to get the remainder of dividing number by 10. So num mod 10 will give me the rightmost digit, and to get the remaining numbers, if I remove 1 from 1001, what I get is 100. To get the remaining digits, I have to perform num divided by 10. I have to get the quotient. So num divided by 10 is 100, that is the remaining digits in the number. and this is my recursive function. Binary to decimal, it takes a number as an input. This is the stopping criteria. This function goes on calling itself repeatedly, but when should it stop? When I find a number which when divided by 10 should be equals to 0. The stopping criteria is basically that as soon as you reach a single digit number, you need to stop the recursion, as in over here. Binary to decimal 1, this is the last step of my recursion. Single digit number divided by 10 will always give you 0 point something, so it is 0. This is when you have to stop the recursion. For all the other times, each time I am calling binary to decimal with the value num divided by 10 with the leftmost values. So 1001 divided by 10 gives me 100. So I am calling binary to decimal of 100 into 2 plus the rightmost digit. So binary to decimal of num divided by 10 to get me the remaining leftmost digits into 2 plus the rightmost digit. So this goes on continuing until I get a single digit number, therefore giving me the final value of the binary to decimal conversion.